Okay, hello. So today we are going to go over a 30, 60, 90 triangle. All right, now very important when we're dealing with the unit circle. But here we're just going to strictly look at this triangle and where it comes from and how all the sides are related. Now, what you see here is an equilateral triangle. All right, equilateral meaning all the sides are the same. All right, now a couple of properties here from geometry is, well, if all the sides are the same or congruent sides here, the angles opposite have to be the same as well. So in this case, what that means is that if all three sides are the same length, then all three angles must be of the same measure as well. Right? In this case, knowing that the sum of the angles in all the triangles of all the angles in a triangle is 180 degrees, right? Evenly split up into three gives us 60 degrees. Okay, all right, so now each of these angles is 60 degrees. Now, where does this 30, 60, 90 triangle, and again, a 30, 60, 90 triangle is a special right triangle. Now, we don't have that here, right? We have an equilateral triangle. A right triangle property is that it has an angle of 90 degrees. So as it turns out, if we construct a, let's say, angle bisector where we cut this angle in half, right? It turns out cutting this angle in half also cuts this side in half as well. Again, another geometric property. So we focus on, here we have an angle bisector, turns out to be a perpendicular bisector to the side. So now we have this right triangle, right? So I'm going to redraw this, half of this equilateral triangle here. Right, so let me move down here, and we'll draw this to look something like this. Okay. Okay. All right. Now, a couple things here. All right. This angle bisector also bisects this side. So the hypotenuse of our now right triangle is side S, right? So S is just some fixed value. Okay. Here, since we bisected this side, this now becomes 1/2 S, or sometimes written as S over 2. Okay, now the angle here is 60 degrees, and since we bisected this angle, half of 60, that becomes 30 degrees. Okay, so now we have that 30, 60, 90. What I don't know is the height of this triangle, right? This is unknown. All right, now I don't want it as x, as an unknown, but I do want to relate it in terms of the side s, right? Remember, s is a fixed value, okay? And in our unit circle application, we'll choose it to be 1, but for now, we just keep it as fixed. Okay, so I'm going to solve using the Pythagorean theorem, right? Remember, the Pythagorean theorem relates the three sides of a right triangle, right? Where we have the hypotenuse, which in this case is s squared, right? S, I'll square it, and I relate it to the two legs, s over 2 squared plus x squared. All right, and now I will solve for x. Okay, so this remains s squared. Here we'll square the numerator and the denominator. And now it becomes a matter of solving for x squared. So I subtract both sides by s squared over 4. Right, so that becomes 0 here. Now remember, this is 1s squared. So 1s squared minus a 1/4 s squared leaves us with 3/4 s squared equal to x squared here. Okay, so now we take the square root. Right, now when we take the square root of a square, usually we want to write plus or minus. But since we're dealing with lengths and geometric figure, right, the natural choice would be the positive, since we're not considering negative lengths. All right, once we have put stuff in our coordinate system, then a plus minus would make sense. But here, it's just simply plus. So properties of square roots here, since this is all multiplied or dividing, we can take the square root of each individual factor here. Square root of 3, I'll leave exact as root 3. S squared is S, and square root of 4 is 2. And of course, square root of x squared is x. Okay, so now let's go back and let's update our triangle here. All right, and actually, let me write this on a new page here. So we have our 30-60 triangle. Where we have it of side S. This is half of S, and this is root 3 over 2 of S, right, from our previous calculations. Okay, so now we have this 30-60-90 triangle. We have all three sides related to some fixed value S being the hypotenuse. Now when we transition to our unit circle, that hypotenuse is going to be a radius of a circle of unit 1. So for our unit circle purposes, let's just let S equal to 1. All right, now how would that, now we can see, all right, so when S is equal to 1, we have our 30-60-90 triangle. Where this is 1, this leg is 1/2, and this leg here is root 3 over 2. Okay? All right, and again, we can orient it in this direction if we kind of look at this here, right, where this is 30 degrees, so then this leg is root 3 over 2, and that opposite leg is 1/2. All right, now I just show you that when it comes into the unit circle, discussing the unit circle, just so we can get an idea where those values come from. But that is our 30-60-90 triangle. Thank you.